standing between me and the happy hours. I'll try to get over it as far as possible. Thank you to ARC for giving me the third chances. Now I'm now in the third year consecutively since 2015, 16, 17, now 18. So I'm in the third year. So maybe I'll be coming next year. Okay. Today I'm going to talk about challenges in implementation of this smart field tanks level unguided wave radar, or sometimes we call it free space radar, online on the tank, and how it creates values in terms of eliminating process safety incident. Basically, this is actually an extension from this morning's process safety track, because this morning talking about process safety, this is some linkage to that extension. If you ever be able to come to Malaysia, you can see the Twin Towers, our standard headquarters for Petronas, and we are the proud sponsor of Mercedes Formula One, 4-time champion so far, so good. We are the first to float the floating LNG, okay? Petronas floating LNG. We are now producing 6 cargoes now. Our 6 cargoes for floating LNG. We are actually all over the world. You can see the dotted line there, downstream, upstream, and the project delivering technologies. Okay, and our business is basically fully integrated business. And we are producing LNG, also producing crude oil, we process crude oil, become refining, and also petrochemical businesses. So this is the products. So I'm from refineries and petrochemical integrated plant located north of Kuala Lumpur, 4 hours from Kuala Lumpur. I would like to share my part of story on the importance of having the overfield protection system. And okay, in terms of instrumentation, we can see, taken from UK HSC data, 44% of the failures of the instrumentations due to incorrect or incomplete specification, the 20% due to changes after commissioning, the rest are operation maintenance, installation commissioning. I would like to focus on that incorrect and incomplete specification that I would like to elaborate today. Okay, from 1971 until 1996, there are about 28 numbers of process safety incidents all over the world. One of them is the famous, okay. After 1996, the history repeating. Process safety incident continues to occur. The Barnesfield incident, the famous Barnesfield incident. The one that I color red is related to issues on level control monitoring, failure of overfield protection safeguarding. 2005, 2009 in Capeco, Puerto Rico. Okay. Little bit of the detail of the Barnesfield incident. This is the high-level alarm. This is the gauges. And this guy failed to operate on demand. Burned 5 days, 43 injuries, USD 1.2 million, 2,000 evacuated. Why? Tank level control doesn't work. High level doesn't come in, did not come in. And also happened to Capeco in Puerto Rico. This is so important. This is where I come into the ensuring that Petronas, the tank farm, is adequately protected. We do the IPF study, the Instrumented Protective Function study, back in 2013. And part of the study was we discovered that in one of the tank farms, we don't have a dedicated safeguarding system. We are having a shared system to do the control, monitoring, and safeguarding. That is not in compliance to the functional safety standard 6111, 6151. So what I did was, during that time, 2013, come up with a project, and we built a dedicated SEAL3 IPS PLC Honeywell, complete with the newly installed dedicated, actually unguided free space radar transmitters for level measurement. So that has improved the tank overfill protection integrity based on the IEC 61511. So my next slide will be talking about the challenges in installation of this overfill protection system. As an overview, we have this Yokogawa backbone DCS, and we install these Honeywell safety PLCs, and we have about 42 numbers of tanks that require to be equipped with the safeguarding transmitter level, the unguided wave. And there are three types of tanks. But before I go on with that, I would like to do a little bit of education here. Maybe some of us not really understand what is the free space or unguided wave radar. It is basically a transmitter which will emit the pulse from the cone to the surface of the target level, and upon reflection, the transmitter will measure the time it travels from emission back to the reception. Knowing the time, knowing the constant, the speed of light, and we can come up with distance. From that, we come up with the level measurement. Okay, back to the story of Petronas refinery tanks. We have three types of tanks: a fixed roof tank, we have floating roof tanks, and internal floating roof tank. Normally, the floating roof tank is targeted for a volatile product, and fixed roof tank is for the non-volatile product. And the internal floating roof tank is for the product which can be poisonous, like MTBE product, which is stored under internal floating roof. It is volatile, but it has to be under closed environment because of the potential corrosion and poison. So we have 20 roof tanks, fixed roof, 20 floating roof, and 2 numbers of internal, which required to be equipped with the transmitters, with the level transmitters. But the challenge is, this is online tank. We cannot simply evacuate the products because online. So that is the challenge that I'm going to explain. Okay. If you look at the fixed roof tanks, we have about 20 numbers of the fixed roof tank, and we have already an existing ATG from Amazon, and looking at the target level. So we don't have any more main hole to install the new dedicated safeguarding transmitter. We cannot share anymore from this. Last time we are using this as safeguarding for control and for monitoring. We need to have another one. So we have to think about how to install a new safeguarding transmitters online. So what we're doing is, we are actually install a T bracket and remove slightly the breather, and then put in the new transmitters which can see the liquid level. This is a quite clever method, and we save from having to shut down the tank, waiting for tank schedule maintenance, maybe 10 years later, maybe 1 year later. But we cannot wait because we are actually in danger of having the potential bounce field incident. So we do this one. We completed the job, no problem. Fixed roof, quite easy. Next is, this is a little bit tricky, the floating roof tanks. And when I say floating roof tanks, this roof will be moving together with the liquid. If the liquid is being filled up, this roof will actually move up to this level together with the transmitters. So now, where can I actually install the new safeguarding transmitter, the dedicated ones? So I cannot drill this hole. This is really a volatile product. So what we are doing is we are putting on the edges of the tank the new transmitters. It looks like this. Okay, soft problem. But the challenges came when it was commissioned. Within the 1 year of installation, operations started to complain about the deviation between this guy's reading and this guy's reading. This is existing control monitoring transmitters. These guys have a perfect view of the liquid interface. This guy does not have a liquid interface. It is using the metal bracket as the interface level. So you can imagine, ideally this roof is not actually same level with a liquid. There's always deviation. That's number one. And number two is, if you look at the surface of this tank, the roof tank, the rooftop of the floating roof, there's a lot of metal object here which can cause the energy of the free space radar to be diffracted. So by the end of the day, sometimes you can get a good reflection of energy, sometimes you don't get. And when you don't get, you get intermittent incorrect reading in comparison with these guys. And luckily, we have these guys reliable by making sure that we do a proper maintenance. So operations is doing a deviation checking between this guy and complaining to us. So the strategy now is to make good of this. So what we are doing is, after a collaboration with analysts houses, and they come up with this. This is an example of showing from the top view a lot of metal object on the roof that can cause the diffraction of the energy from the transmitters. You can see a lot of objects here from the top. So what we are doing is they recommend us to install the reflector. Okay, this is there's a reflector. Okay, you see. Okay, we install reflector. This is the gravity radar, and we put a reflectors here. This is the picture of the reflectors. So what does the reflector do is it guarantees a good target and stronger reflected echo, right? And from this, we are able to achieve a consistent reading of the level. That's one of the issues. Another issue is that when we put on the edge of the tank, there's a lot of mechanical movement, a lot of hinges here. These guys can move, and the bracket has to be very, very strong. So we improve the mechanical installation by having a bigger hole and put in the right extension and support. And by doing that, it's improved the mechanical sturdiness of the installation. So by doing these two things, we are actually able to improve the readings. And this is actually an overview from the top. You can see these reflectors. And you can see a very good reading. This is actually an example of tank filling from the bottom to top. The blue one is the safeguarding transmitters reading. The green one is the control monitoring ATG from SAP. And you can see they are consistently following each other within less than 200 mm. Our specs is deviation alarm is 200 mm. But our management is not happy with 200 mm. They say, I want below 200 mm. So right now we are actually looking at ways to further improve the deviations. Sometimes it can achieve 50 mm, sometimes it is deviated by 100 mm. So we are actually looking at ways to further improve the deviation from this guided wave radar, unguided wave of analyst houses, and the unguided wave from ATG SAP. ATG SAP is using the frequency modulated continuous wave. Analyst houses using time domain. So there are actually two different philosophy, two different principles, which is very good because they are checking each other using different principles, but still come up with almost the same numbers of level, you can see here. So we're actually looking at ways to further reduce the deviations. Okay, as a conclusion to my presentation is the installation of unguided waves of free space radar level transmitters for safeguarding improve tank overfill protection integrity, thus eliminating process safety incident and full compliance. And for your information, before this installation, we have issues of tank overfill in one of our diesel. Right now, we have, so far, we don't have any more issues because of the independency between the monitoring control and also the safeguarding. With that, I thank you very much.